Because making secure passwords requires a substantial amount of work, we'll break our password attribute down into two pieces. We'll start with insecure passwords, just to get things basically working, and then we'll add a security layer. So let's get started now with insecure passwords. To get started developing passwords, we'll need to bring up our terminal window. Here it is, and our editor. There we go. And I'm going to close the gutter for the bulk of this lesson, and I'll be navigating using Command T in TextMate. But you should feel free to refer to your directory structure just to remind yourself where the files are. Now, the task of this section is to put a password attribute on our user model, and you might be tempted to run a migration at this point to add an actual password column in the database. But it turns out that that's not what we're going to want to do. If we wanted to store passwords unencrypted in the database, we could do it that way. But that's a terrible security breach. So what we're going to do in this section is lay the groundwork for the encrypted password in the next section. We'll actually make the encrypted password column in this section, but we won't do the actual encryption until the next section. So let's get started with our test-driven development. Let's take a look at Autotest here. Just make sure that it's green. Good. And so what we're going to be doing is creating a password that requires a confirmation. This is a typical pattern on the web. In order to cut down on erroneous passwords, we'll have a password field and then a password confirmation field. In fact, let's take a quick look at a mock-up of what the sign-up page will eventually look like. So we see that we'll have a sign-up page with fields for the name and email attributes, and then the password and a password confirmation, and then a button for signing up. The goal of this section is to add to our user model the password attribute and the password confirmation. Now, when adding attributes to models, I like to use a special method called respond_to write a test for the attribute. So let's take a look at how that works. Here in the fifth tab over, let me start a console. So let's do user.new. Let's just assign it to a variable. And now let's say user.respond_to question mark, and then a symbol, which in this case will be name. So we'll see if the user object responds to the name method. So this is the same as saying that this user.name actually has some sort of value, or that it works. We can also do user.respond_to say foobar. That's false, and of course if you do this, it raises a no method error exception. This means that we can test for a password attribute in our user spec. So let's open up the user spec. Now you may notice that the entire set of user tests is inside this describe user do block. We're going to make another describe block. We're going to nest one inside here. We're going to say describe passwords should have a password attribute. And now what I'm going to do is user.new of @attr. Remember, we have an attributes hash up here. And this actually returns a user. So I'm going to say should respond to password. We see that it fails because we don't actually have a password attribute. So let's just go back to the console and see how this is working. So I'm doing user.new, and then say name is foo, email is foo@bar.com. This returns a user. So inside here, this is the attributes hash right inside this argument. And now I'm saying respond to the question mark and then the attribute. So it says false because it does not respond to password. Remember, the convention in our spec is that anytime you have a Boolean, you can turn it into a test. So you see what this does is this creates a new user, and then this says it should respond to password. And what's happening here is RSpec is calling respond to question mark on this user created by user.new. And in this case, it should respond to password, but it doesn't because we haven't defined it yet. So now let's take a look at the user model. Now we could run a migration and actually add a password column to the user model. But as I mentioned before, that's not what we want to do. We're actually going to use an encrypted password in the database. This password is actually just a virtual attribute. And when I say virtual attribute, I mean it's just a normal Ruby attribute created by attr_accessor. So I'm going to create a password attribute using attr_accessor. And remember, this creates the getter and setter methods needed to manipulate passwords. So you can say user.password equals something, and so on. So I'm going to save that and see if our test passes. Good. So now we actually do respond to the password. The user model responds to the password attribute call. So this, when you do, can do this here, reload bang. And now let's see if this works. Yes, so this little attr_accessor actually gave us the password we needed. So now that we've got our first test passing, let's write another one. It should have a password confirmation attribute. Let's say, let's just copy this. Actually, let's do it before each block here. At user equals user.new at attribute. So then I'm going to say at user dot should respond to password. Actually, let's just make sure that works. Anytime you do a little refactoring like that, it's nice to see that you're still green. Good, we're still green. So now I'm going to say it should have a password confirmation attribute. So at user dot should respond to password confirmation. All right, now I'm going to leave this red for now because it turns out we're going to be able to get this password confirmation attribute using a little bit of Rails magic. So if you look here, we could add a password confirmation attribute here. We could do something like password confirmation. This would get us to green, but this is actually not how to do it. The way we're going to do this is with a special kind of validation. So let's start on a new validations block here in the user spec. Let's make a block for describing password validations. And let's start off with something we know for sure, which is that it should have a password. So we'll say it should require a password. And let's do user.new, and now we're going to use our merge trick that we learned in the last lesson. We're going to say, here's the attributes hash dot merge password is blank, and we're also going to say that there's no password confirmation. So it's just an empty string for each of these. And this dot, now notice I can break this across a line. If I have the dot at the end, I can say dot should not be valid. This is a little bit of Ruby syntax here, just seeing that you can actually have a new line here, but this dot is really important here. Because this is fine. It's okay that we're red because this shouldn't have passed. So at this point, I'm going to say that it should require a confirmation as well. So it should require a matching password confirmation. So this is an invalid password confirmation, and this should not be valid. All right, so let's go back to the user model and add in a validation. You may be able to guess how to do this. So we want to validate the presence of a password, so that's presence is true. And then we're going to use a special validation called confirmation. Go in here and say confirmation true. What this will do is require the confirmation, but it will do something even more than that. It will actually create automatically a password confirmation attribute. So we're still red. Let's go take a look. There are a bunch of things we're doing wrong here, but this is part of the great thing about test-driven development, is that it'll help you get to green. Okay, you'll notice password can't be blank. User.createBang. So we've added a validation that says that we have to validate the password with presence is true, but what's happening here is that the user.createBang is failing. So remember where that is. That's all the way here at the top, user.createBang. And the reason this is failing is because the attributes hash is not valid, because we're now requiring the presence of a password. So we need to add a password and a confirmation to this thing here. So let's do that. So we need a comma here, and then password. Let's just say foobar, and password confirmation is also foobar, and save that and see how it goes. It'll still be red, but let's take a look at what we did here. So now it says password can't be blank. User.createBang here with the email addresses identical up to case. We're having the same problem. User can't be blank. And so this is the kind of thing, or sorry, password can't be blank. And this is the kind of thing that it will happen to you, and then you'll wonder what the problem is, and then you'll realize that you actually haven't made that attribute accessible. Remember, everything that's accessible through the web needs to be in this line, and these are exactly the kind of things that you're going to have to change through the web. And in practice, what it means is that if you can pass the attribute as part of a hash like this, an initialization hash, it has to be in the attribute accessible list. So let's save this and see how we're doing. Look at that. Now we're green. So all of those things that were failing were due to accessible not having password and password confirmation. So let's go back and look at the user spec. So let's see what we've got passing now. So this was failing before. Now at user, this user that we created here, this new user that's just exists in memory, now it does respond to password confirmation. And that's pretty cool, because if you look over here, we actually haven't defined any sort of accessor for password confirmation, and we don't have a column for that either in the database. The reason this is working is because when you validate confirmation true, Rails automatically creates an attribute corresponding to whatever this is, in this case password, with underscore confirmation. So that's why this is passing, and it should require a password. This is passing now because we have this the presence validation right here. And the final test is passing because up here at the top, now we've got password foobar, and when we do this at attra.merge, password confirmation invalid. Invalid does not match foobar, and so now this is not valid, and as a result, this test passes. Now there's one more validation we want to add to this password attribute. Typically, passwords have some sort of minimum length, and we're actually going to implement a maximum length as well. So let's do that. Let's have a test that says it should reject short passwords. Now, in this case, I'm going to make a short password. I'm just going to call it short. And remember how to make a string of a particular length. We can do something like just some string, in this case a, times how long we want it to be. So I'm going to make it length 5, because let's say that our passwords will be between 6 and 40 characters long. So at least 6 and at most 40. So this is a short password. And now we can do the same thing we did before. Let's make an intermediate variable, though. Breaking this across a line is okay, but it's kind of annoying. So let's just make a local variable called hash, which is the initialization hash, and I'm going to say at attr.merge. Password is short, and so is the confirmation. Password confirmation, short. And so now I can say user.new with this initialization hash should not be valid. I want to reject short passwords, so this new user should not be valid. Let's save that. Should be red. Good. And let's we're actually going to get these both in one fell swoop. So I'm going to say it should reject long passwords as well. In fact, we can just copy this. So let's say long is a times 41. So this will require that the longest password is 40. So this is one more than the longest. Long. And so this should also not be valid. Good, so now we're red. And recall that before we were able to implement a maximum length on the user model name. So let's take a look at how we did that. Validates name, length, maximum 50. In this case, we're going to do something similar. We're going to say length, but instead of a maximum, we're going to say within. And then this is pretty cool. We're going to give it a range. Remember, we've talked about ranges before. Now we can say it's within 6 up to 40. So 6.40. This requires that passwords be within this range. And so if I save it, we should get to green. And there we go. So this sort of process where we write just a little bit of code in the test, say at user.shouldRespond to password, and then we write just enough code to get it to pass, is really the heart of test-driven development. And notice that we haven't been working very much with the console. That just for purposes of illustration, I've used the console a little bit. But once you have some experience writing Rails applications, you can just go back and forth between the test and the application code, and it gets you into this sort of rhythm. Red, green, red, green. Now, some configurations of Autotest will automatically rerun the entire test suite when we get back to green. I have mine set only to rerun the particular tests corresponding to this file, in this case, the user spec. But once you reach some sort of natural stopping point, it's often a good idea just to switch over, do Control-C, rerun the entire test suite just to make sure that everything's working. And there we go. Now, at this point, you might notice that we're not actually storing this password anywhere. If you look at the user model, this @accessor, this applies only to user model objects in memory. In order to save something to a database, we actually have to make a column in the users table. And then Active Record will automatically look at that column and notice that it should make an attribute for it. So we do need a place in the database to store the password. And since the actual stored password will be an encrypted password, that will be the name of the column. So let's make a migration to create an encrypted password column. As usual, our first step is to write a test. So let's make a new block down here. Describe password encryption. I'm going to say it should have an encrypted password attribute. And I'm actually going to put in it before each block. And I'm actually going to create the user. As we'll see, this step is necessary. So this creates the user in our test database. And then this user, @user.should respond to, remember, we pass it a symbol, encrypted password with an underscore. So I'll save it, and we should be red. Good. So now let's write our migration and get this to green. Now you may recall from the last lesson that we wrote a migration to add an index to the email attribute of the users table. In that case, we just used a convenient name for the migration. But in this case, we're going to use a special name that will actually cause Rails to do something useful. So let's see how that works. Rails generate migration And now I'm going to say add, and I'm going to give the name of the kind of attribute I want to add. This word here isn't actually that important. I'm going to use the word password. You can say anything here, but then I'm going to say _to_users. And this will cause Rails to automatically add whatever I'm going to put next to the users table. So let's do a / to continue the line. And now I'm going to put the name of the attribute and the type of the attribute. So I'll show you that, and then I'll explain it. Encrypted password : string. And you should compare this to the way we've previously generated scaffolds and models, where we put the data model on the command line. Here, what we're going to do is create a migration that will add the password to the users table, and Rails will automatically know to make it an encrypted password of type string. So let's do that. Okay, let's take a look at that. Add password to users. And so notice what happened here from that migration. Rails automatically knew that we wanted to add a column to the users table of name with an attribute name, encrypted password, and of type string. And it's even already done the remove column for the down part. So let's migrate this database. Rake db migrate. And remember, this will create an encrypted password attribute for the user model corresponding to an encrypted password column in the database. In fact, let's annotate the model. So we annotated the user model. Let's go take a look at it. And so you can see we've got an encrypted password annotation here corresponding to that column in the database. Now you'll note, though, that we actually were red. Let's save it again. Now you may be wondering, why is this red? Because since we now do have an encrypted password column in the database, Active Record should automatically be giving us an attribute corresponding to that column. And the reason it's not working is because we've migrated the regular database, the development database, but we haven't migrated the test database. And remember, the way to do that is to prepare it, rake db test prepare. So now let's go back and run our test suite. Now this should be green. Good. Now before moving on, I want to show you a useful technique, in case you're not using Autotest, to run just a single example. In fact, this is sometimes useful even if you are running Autotest, because sometimes some example isn't working, and it's just so annoying that you just want to run that one example over and over again until you get it working. So let me show you how to do that. The way to do it is rspec at the command line, and then the path to the file you want, which in this case is spec models user spec. And now you don't need to continue it onto the next line in general, but usually you'll want to. So what I'm going to do now is pass it a flag, -e for example, and then the string that's inside this guy here. It should have an encrypted password attribute. So let's copy that. And that runs just that one example. So this is quite useful. As I mentioned before, I usually use Autotest, but sometimes I will drop down into this command line version if I want to run just one example. So now that we're done with that, let's add all of the files that we've got in our project and make a commit. Now, at this point, we have a working encrypt password attribute, but it's still not doing anything. The whole purpose of this attribute is to store an encrypted password in the database. Remember that the password attribute here, this password created by @accessor, only exists in memory. It only exists in RAM, but it doesn't get written to the database. What we need is some way to actually write the encrypted password to the database. Later on, we'll have a more sophisticated test for this, but right now, let's just go back to our user spec and say that after a user actually gets created in the database, it should not have a blank encrypted password attribute. So let's say password encryption, it should set the encrypted password attribute. Of course, eventually we will be testing exactly how the encryption works, and we'll make sure that that all the machinery is working properly. But at the very least, it should not be blank. So at user dot encrypted password dot should not be blank. And so we need to start up Autotest again. And we are red as expected. Now, I just want to show you how this works. Let's open the console in a sandbox. Let's get out of this. Remember, Rails C, we can do -- sandbox, but -s is a shortcut for that. Okay, now let's actually create a valid user. Let's say user equals user.create bang. So that created a user in the database. Of course, it'll be rolled back once we go out of this session. That's the whole point of the sandbox. But you'll notice that even though everything worked, the encrypted password is nil. And the reason for that is because we're not doing anything with it. We could try writing to it directly. We could say user.encrypted password equals foobar. In that case, it actually worked. So you'll notice that we do have an encrypted password attribute, and we can write to it directly by accessing it using the dot operator. But what we want to do is actually have this sort of thing happen before the actual object gets saved. So in other words, when we call user.createBang, before it gets saved, what we want to do is set the encrypted password equal to an encrypted version of the actual password here. Of course, here I just set it equal to the password itself, and that's what we're going to do at first, and then we'll learn how to encrypt it later on in this lesson. Oh, by the way, you might notice that we're using the blank method. This is a method that's not currently part of Ruby, but it is part of Rails, and eventually it'll probably be part of Ruby. It's very useful. So empty, the empty string is empty, and it's also blank. But a bunch of spaces is blank, even though it's not empty. And nil is also blank. So when we say that the encrypted password should not be blank, we want to make sure that this case here, that we saw right here, we want to make sure that the encrypted password is not nil or something else that's blank. So let's go over to the user model. And what we want to do here is register a callback. So register just means put in the code necessary to tell Rails that we're defining a callback. And a callback is a method that is called at a particular time in the life cycle of an object. In this case, what we want to do is set the encrypted password attribute before the user object gets saved. So the way to do that is as follows. We do before save, and then the name of the callback, and I'm going to call this method, or this callback, encrypt password. And now that we've registered an encrypt password callback, what we need to do is define a method called encrypt password. Now, since the method encrypt password will only be used inside of the user object, we're going to make it what's called a private method. It's a good practice to make methods private unless they need to be accessible from the outside world. And we'll see in a moment exactly what that means. So first, let's just define this encrypt password method. And save it. We'll still be red. Let's take a look at the console here. I'm going to reload it. And let's say, let's just up arrow to our user. And now notice that there's an encrypt password method here in our user model. So we should be able to call it user.encryptPassword. And you can see that we get a no method error exception, but there's not really no method. It's actually a private method. Private method encrypt password called for user. So that's what it means to create a private method. It means that we can only use this method inside of the class itself. We can't call it on a user model object using the dot keyword. So what do we want this encrypt password callback to do? What we want it to do is set the encrypted password attribute of the user. And we saw at the console that we did that using user.encryptedPassword equals. But in the context of the class itself, the user object is represented by the keyword self. So we're going to say self.encryptedPassword equals, and then we're going to create another private method to do the actual encryption. So we're going to say encrypt. We haven't defined this yet, but we will shortly. Encrypt, and then the password corresponding to this user. Now, remember, there's an @accessor password, and the way we would normally access that would be to say user.password, but inside the class we can say self.password, and that will access the password attribute for this user. Now, it turns out that inside of the class, if you're trying to get one of these attributes, you can actually omit the self keyword. If you just say password, Ruby will know that what we mean is the password corresponding to this user. So typically I will omit the self keyword because it's a little bit verbose. So you may wonder why I put it here. And the answer is because if you omit it here, what you end up doing is creating a local variable called encrypted password. The only way to tell Ruby that you actually want to change the attribute on the object is to say self dot and then the name of the attribute. Now at this point, we're going to define the encrypt method. And it takes one argument, which I'm just going to say is a string. And then down here, we're going to encrypt it with some sort of algorithm later on in this lesson. But at this point, let's just return the string itself and emphasize that this is not the final implementation. Of course, this isn't encrypting it at all, but there's so much going on here that it's good to defer the actual encryption until later. Let's save it and see if you can guess what will happen. There we go, we're green. So the reason we're green is because before a user object is saved, we're actually setting the encrypted password attribute equal to the encrypted value of the password, which right now isn't actually encrypted, but as I mentioned, we'll be dealing with that later in the lesson. So let's remind ourselves which test this was. It's this one here. User.encryptedPassword should not be blank. So what's happening here is when user.createBang is getting called, before the actual save to the database, the callback here, the encrypt password callback, is being called, and that's setting the value of the encrypted password equal to the password itself in this case. And at this point, our user model is basically working. If we were willing to store unencrypted passwords in our database, we could actually get this to work, but that's not acceptable for a real application. And so in this next section, we're going to fill in this line here inside the encrypt method and actually get it to be a real encryption. And as we'll see, that will introduce some extra complexities, which we'll deal with as they come up.